worksheet?
It's 4.
If you said something I didn't hear, didn't
Oh,
understand.
sorry. 4.
4, yes, and let's do 4 next. Okay, let's look for all the ones that are of this type. Okay, so this is very similar to the previous one. You want to find two numbers that multiply now to -6, but add up to +5. Does anything come to mind?
-1, 6.
Okay, those do work. So this becomes x -1, x plus 6.
Am I talking too quiet?
Say that one more time.
Am I talking too quiet?
You're okay. You're okay. I can hear you. Just want to make sure I can, if you have a question that I don't miss what you say, but it's fine for me. So 6 is like 4. Why don't you try 6 for me?
X -5 and x plus 8.
X -5, x plus 8. Perfect. All right. So we've got, this is all you wanted to work on today? These problems?
Yeah.
Okay, so we should do 7 next because it's like these ones. We'll come back and do the other ones. This one's, I think, the easiest case because they're both positive.
X plus 5 and x plus 4.
Perfect. Yeah. So it's so much easier when you identify the type there. So let's do one more of these, and then we'll jump back to the original. We'll go back to number 2, see something different.
X -2 and x -4.
Perfect. Yeah. Really good. Okay, so let's go to actually number 3. We'll come back to 2. So 3 here, 3 is a GCF problem. Okay, and I'm telling you that because you really, like, once you've done a bunch in a row, you don't want to forget you don't want to forget that, yeah, you always try GCF first. So you're looking for a number that goes into every single term. And I think you can see that that's 6. So you
Yeah.
divide each of these by 6, x squared plus 4x plus 2. Now this one it looks like you can do more, because it looks like one we've just been doing. It's like, okay, a equals 1x squared plus 4x plus 2. But when you write the 2, the only factors of 2 are 1 and 2, and that certainly does not add up to 4. So you are done at this point. You're completely done.
Oh.
So sometimes it is left in this form, but not always. Okay, and that's so the challenge with factoring is like, well, when am I done? When do I stop? And the answer is I can't tell you until we look at a question and you try everything. But inevitably on a test, it's like, well, did I try enough? Okay.
Yep.
So let's look at number 10. Okay. This one does have a GCF. That's why I'm showing this one to you. Again, because I want you to always look for the GCF first. Makes your life easier if you look for the GCF. 2 in this problem. So when you divide everything by 2, you get x squared plus 8x plus 7. And question to you is well, does this factor?
No.
So you cannot find two numbers that multiply to 7 but add up to 8. That's what you're saying.
Yeah, 7 is prime number.
That's okay. 1 and 7 though.
Wait. Oh wait. Oh, how did I miss that?
Well, your brain, the brain's is a great, I don't know if it's a muscle organ, whatever. It's like it gets trained and you think, oh, well, I just did one that didn't work, so this one doesn't work. And you see, oh, 8's bigger than 7, so it must not work. But if it's 1 bigger, it always works. Whereas the 4 is 2 larger than 2, which does not work. So this one does factor. This is 2 times x plus 1, x plus 7.
I really got to watch out for that.
Yes, the details. I'm just looking to see if there's another one. Does this just go up to 21?
Yeah.
Okay. All right, so let's do another one of these GCFs. Let's do 11. 11 though is more than just a number in terms of its GCF. Let me get that snipped in here. Okay, so can you tell me do you remember how you deal with the exponents and the variables for the GCF?
It's so for this situation, it would be 5, and then you take the lowest.
That's right.
On it, and then
yeah, so 5x squared. Why don't you tell me what goes inside parentheses when you divide here?
x squared dx plus 10. Yeah. Am I talking too quietly again?
A little bit, yeah, but that's okay. I hope I can get you to just a tiny bit more. Okay, now you have to decide if this is factorable. Two numbers that multiply to 10, but they have to add up to +3.
Don't think there is.
Yes, you make the full list, and it's not that big, but there's the list. None of those add up to 3, so you're done.
Okay.
Okay, so now you know enough now to try 12 on your own. And let me know if you have questions, but give this one a try. It's very much like the last few that we've been doing.
I got x plus 2, x plus 5.
Okay, did you factor out a 3x first?
Yeah.
That is also part of your final answer. Like if you just wrote what I'm about to write here without the 3x, it would be marked wrong. You have to give the entire factored form. Is that okay?
Yeah.
Okay, so another one to try that's similar is number 20. Have you tried number 20?
I'm sorry, but the fact that it's x to the third power It's kind of psyching me out.
Okay, yeah, no, this is where I want you to say, hey, I don't understand, I'm not sure. If this were in person, I could read your body language and see like your eyes would just be like, I don't have any idea. I could just read that. But so the GCF is a variable only. Like sometimes it's a number, sometimes it's a letter, and sometimes it's both. So if you divide each of these by X, it's now going to be in a form that you can work with.
I was kind of
So
thinking it was like one of the earlier equations with
yeah, and it is now.
X.
It is now. You've done a lot of practice. I mean, if I think about every homework set, I mean, you've probably done at least 100 of these factoring. So your expertise has increased, but this one inside parentheses, it's like the first couple that we did. So go ahead and try that one for me, please.
Yeah, X plus 1 and X minus 4.
Okay, is this your final answer?
There's an X in front of.
Yes, very good. Okay, very good. All right. 21 is like it, and then we'll go back and kind of restart with some different problems. Again, I'd like you to try this one start to finish. There is a GCF. Not sure beyond that. You'll have to decide if there's more to do, but please ask if you're not sure. Just say,
I got X minus 1 and X plus 5.
like this. What?
X
Anything?
in front of it.
5x in front or more? Okay, great. So let me just quickly check here. That sounds right. These are hard to do without actually writing out the numbers here, but yeah, that does work. Perfect. Okay. So slow and steady, right? You don't want to rush through these. Let's go back and we're going to look at number 2. So if you recall that list that I wrote earlier, the first thing you look for is a GCF, but there's no GCF in this one. It's 4, 4, and 3, x squared, x, and no x. There's no GCF. Okay. It's not difference of squares, because difference of squares is 2 terms. All right. It's not a perfect square trinomial. We'll talk about those in a moment. It's not the a equals 1. So it must be this a not equal to 1. And with those, you take this first and your last number and you multiply them together. I hope you remember us doing that. So now you're looking for two numbers that multiply to -12 but add up to +4. And there's your full list.
-2 and 6.
Yeah, so you break apart the 4x squared. We'll go 4x squared minus 2x plus 6x minus 3. They call this a diamond method. I guess I really need to see what they're doing in the classroom. And then now you find the GCF of the first two, which is 2x. And then you write what's in parentheses off to the side. We spent a bunch of time doing these, I think 1 or 2 lessons ago.
Yeah.
And then it's looks like it's +3 inside here. So 2x plus 3 times 2x minus 1.
Yeah.
So on your test or quiz or whatever you got upcoming, like you're going to get at least one of each. And you may want to use this approach that we've been doing where you kind of like look for the ones that are like this. Sometimes they're disguised though. And I think that's part of the challenge here. Like these, when they have a number in front that's not 1, you should first look for a GCF. But if they don't have a GCF, then it's most likely going to be this last one where you have to multiply the first and the last. And like I said, we did a bunch of these. The only other one I see that's like this is 18. So we should look at that one next. Okay, so why don't you try this one on your own? Any questions on this, or how are you doing?
I think I'm doing pretty good. 3x minus 2 and 1 plus 3x.
Maybe x plus 3.
Oh yeah.
Okay, so that sounds pretty good because you use the -2 and 9, so it's 3x squared plus 9x minus 2x minus 6, 3x times x plus 3, x plus 3, and then -2. Yeah, this is perfect. Do you feel like this is the most difficult of the group of the types that we've done?
Yeah, it has the most steps.
Most steps, most, room for error
Yeah.
on there. Okay, so we've not done many of the following, which is difference of squares and then perfect square trinomials. So I guess we should do those next. Start with number 5. Here, let me snip that in. So this is difference of squares, and one way is there are two terms. Okay, difference of squares. So you have to figure out what squared minus what squared, like what goes in parentheses so that when you square it, you get x squared. What goes in parentheses such that when you square it, you get back to the previous line, 36. Can you tell me either of those?
Could be x and 36.
I heard maybe 6.
Oh yeah, 6. 6.
Good. So the formula is a squared minus b squared. A squared minus b squared. This is the formula. So in your problem, a is x and b is 6. Okay, and here's the formula. You write a minus b, so whatever your a is minus whatever your b is, a plus b. So in your problem, a is x and b is 6. So it's x minus 6, x plus 6.
Oh.
Any questions on that?
No, it's pretty clear.
Okay, so let's look at 13. What about 13 could be a difference of squares? What is it that maybe gives away that this is difference of squares?
There's 2 terms.
2 terms, okay. But what are you always supposed to do first? What's the first type of factoring you're always supposed to do?
Find the greatest common factor.
Yes. And this one has a greatest common factor of 4x. So even though it's got 2 terms, even though you're like, oh, it's probably GCF, or probably difference of squares, you still want to find the GCF. So when you divide each of these by 4x, tell me what goes in parentheses, please.
X squared minus 4.
Yes. So just like in some of those previous problems, once you do the GCF, you still have all the other types of factoring that could be in play. Okay, so this is difference of squares. So again, it's like what squared minus what's squared gets you back to the previous line. What goes in parentheses?
X and
So your a is x and your b is 2. And so your formula here, a squared minus b squared, a minus b, a plus b. And so what you're going to write is you're going to write x minus 2, x plus 2. but you still have to bring that 4x down. So I know I'm kind of all over the place here on this one, but your final answer is got this form. So there's one more on your page that's got two terms. Can you tell me which one that is?
I think it's
So look at number 8. It's got two terms in it. You know, is it difference of squares? Not sure, because you first need to always do the GCF. Okay, so what is the GCF here?
5.
5, yeah. And so that's 5x plus 1. And you have to recognize that there's nothing more that you can do.
Yeah.
So this is totally done. So I believe the only ones we have left are 14, 15. Is that right? 14, 15, 17, 19.
Yeah.
Okay. Okay, so let's do 15. I guess we just do them in order. Let's try them at some point. We just got to get them all done. All right, so let's do 14. Okay, is there a GCF here? Always start with that. Is there a GCF?
Yeah.
Now this time it's -4 because that leading one is negative. If the leading one is negative, usually you pop out the negative with it. And then yeah, you divide each of these by -4x. -4x. So when you saw that cube earlier and you were like, that looks awful, you know, you probably can do something to reduce it ahead of time. So go ahead and tell me what goes in parentheses here, please.
X squared minus 2x plus 1.
You got it. Okay. Now, what's different about this one is that this actually is a perfect square trinomial. This is probably a good time to bring that up here. So what makes it a perfect square trinomial is the first and the last are perfect square roots. You can take the square root of the first and the last. So what I mean by that is the square root of x squared is x, and the square root of 1 is 1. And that's kind of the start of this. It's not the reason, but it's the start. The second reason is that the middle term, the -2, you pair these up together, you squeeze them together, and then you double it. And if that equals the middle term, then it is a perfect square trinomial. If you don't like that, if you're like, I don't remember that, you do just like we did before. You have to break apart 1 into two numbers that multiply to 1 but add up to -2. So it's 1 and 1 or -1 and -1.
So could that only be the case if the last number is 1? There's no other numbers.
It's got to be a square root. It's got to be a perfect square. It could be, you'll see in some other ones it's different, but this is not the greatest example to show this. It's okay if you didn't like this, but you notice it becomes x minus 1, x minus 1. and they're the same. So that's what a perfect square trinomial is, that the factors end up being exactly the same. Okay, so let's I guess I said we're just going to do these in order. We'll do 15. We have not done enough perfect square trinomials. I'd recommend either us doing some more on Thursday or asking for that in class. Okay, so the GCF, you always start with the GCF. So is there a number that goes into 5, 2, and 7?
No.
No. And then you look at the letters. So like look at the X. Do they all have an X?
No.
Do they all have a Y?
No.
So we're really not doing well in this one. Like this doesn't have much. It kind of has the appearance of a perfect square trinomial because you can take the square root of X squared, but you cannot take the square root of 5. And you cannot take the square root of 7. So this one is prime. That means there's no factors that work. And I think those are almost the hardest because you really want something to work, but it doesn't. Okay, so I think we got 17 still to do and 19. Is that right?
Yeah.
All right, so 17 is really, really distracting. It's got it's got X and Y in it. So for right now, I'm going to tell you to just ignore the Y. Let's just say it was X squared minus 5X minus 36. Okay. Could you factor this for us? Two numbers that multiply to minus 36 but add up to minus 5.
X minus 4 and X plus 5 or X plus 9.
Yes. So be careful there with your signs though, because the 9 ends up having to be negative.
Oh, yeah.
Okay. Because the negative 5, it comes from the minus 9 plus the 4. So that would be true. Like this is correct if it were what I've wrote here, but it's not. It's Y squared. But don't worry, your work is still good. Notice if you add a Y to each of these, that gets you, when you FOIL, that gets you the 36Y squared minus 36Y squared. Do you see that?
Yeah.
And then the only thing it changes with the middle one is it becomes minus 9XY positive 4XY. That gets you the 5XY here. So you essentially ignore the Y squared, or that second variable squared. And you can see that again in number 19. It's essentially the same problem with different numbers. You ignore the Y's. So it's X squared minus 2X minus 15. I want you to factor that, please.
Okay. x minus 5 y and x minus or x plus 3.
Yeah, and then you just throw those y's in at the end.
Yeah.
Okay, great job. We got through all of them, I think. Could you just double check that we've done them all?
Yeah, I think so.
Yeah, I know it's a little odd when we do them out of order, but hopefully that helps. Hopefully that makes